Hello everyone, welcome to this series of videos who is gonna describes how the reality works in the beautiful series of quantum mechanics. Next, in this first video, I'm going to introduce you what is quantum mechanics and how it helps us and how it helps us understanding some of the basics and deepest realities which we miss in everyday experiences. So let me start with the beginning. Of course, beginning was from Newton. Isaac Newton, around 700th century, explains everything from stars, how planets works. He gives beautiful theory of gravity. In his Principia Mathematica, he formulated some of the very beautiful mathematics. It is calculus we all use. So
Isaac Newton gives
another theory. In his theory, he explains how and what is light is. In his theory, corpuscular theory, describes light as a particle. He called it corpuscle, right? It is a very different name, but he described it as a particle. At the time, Newton was very great, very respected scientist. So everybody well accepted his model of corpuscle. So everybody believed light is a particle. So after his death, in the beginning of 1800th century, around, a very talented young scientist, Christian Huygens, asks a very beautiful and important question at the time. That is, if I put a cardboard between you and me, can you see me? Can you hear me? The answer is, you can't see me, but you can hear me, because the wavelength of sound is almost equal to the edges of this cardboard, and that is why it can reflect and travel to your ears. But if this cardboard is put it, but you can't see me because the light waves can reflect to this cardboard, and this describes it's open up a new thinking, but it confounds by Thomas Young, another very young and talented scientist. So Thomas Young's designed an experiment which Euler describes that light is a wave. He has taken two slits and a screen. In this double slit, he fires a light. That light travels through those slits and goes to that screen. You can see that in this animation that there is a beautiful interference patterns formed. You know, when interference as pattern forms, it forms in a waves. When you maybe have done some experiment with water waves. When tops and crest of waves combine together with same amplitude, they cancel each other out at some point, and some point they merge together and it gives more intensity. It is the constructive and destructive interference. He found the similar thing in that double slit experiment. In some point, constructive interference happens due to the construction of those waves interference of the troughs and crest of same amplitude and different amplitudes combining. So in this experiment, he very successfully describes that light is a wave. So at that time, due to that experiment, everybody accepted that light is a wave. So that is accepted for 50 or 60 years at that time. Then Faraday's experiments and his theories, and from this Maxwell's formulated the equations of electromagnetism, and he got very important result that light travels at 300 million meters per second. It is a very important result that helps and shapes our understanding at beginning and lead to this at this time. And it very well it explains very well what is going on. So then after that, around 1900, so many scientists trying to describe and trying to explain the black body spectrum. Black body is a body. Some if you fire some light on a black body, it's almost absorbs every energy you have provided from this light. Its reflection coefficient is almost 0 and absorption coefficient almost equal to 1. The black body spectrums at the time nobody able to explain when, for example, Wend's law able to explain the beginning and the first portion of the curve, and Rayleigh Jeans able to explain the later portion of the curve, but from today don't able to explain completely what is going on. The experimental curve, it is like a bell shaped. You can see that it's in the beginning of 1900. Max Planck, a German physicist, and he's a great mind, and he able to describes how this curve is experimental curve. So Max Planck in the beginning of 19th century able to describe this curve, black body's radiation curve, very successfully. So Planck's theory is very well accepted at the time, and he is awarded Nobel Prize for that. And Planck's theory, he said that the black body is constructed by some of the quantum harmonic oscillators, which oscillates and radiate light and absorb them, and it is a very beautiful mechanism. And I'm going to discuss in later portions of this lectures. And Planck's theory also predict that light is some small portions of packets of energy. Light travels some small packets of energy. He called it quanta. From this quanta word, the quantum mechanics has arise in the future from that time. This quanta of energy, Max Planck describes in his explanation, is very beautiful, and it gives some very good interpretation, which to Einstein's theory of photoelectric effect. In 1904, around that, genius Albert Einstein's, at the time, young Albert Einstein's working on his patent of his around 1904, write a beautiful paper on photoelectric effect. How when you flash some light on a tungsten filament of metal, electrons ejected instantly from when you emit light. And this experiment shows how light works as a particle. This experiment, photoelectric effect, when this electrons ejected, current found in this circuit. So this experiment and this theory explains that light is a particle. Light is a particle. So this result again open up the controversy of wave particle duality. So this wave particle duality going to be very controversial in the later years of the development of quantum theory. In this next episodes, I am going to describe and illustrate to you how Heisenberg and de Broglie, very important, how de Broglie solved this problem and how he describes that light is sometimes wave and sometimes particle. His wave theory, by his theory, and later portions I'm going to beautifully describes the mathematics of quantum mechanics. It's very good mathematics has been used, is going to use in this uh, courses. So this describes how world works, how reality works on the best and fundamental level at, at the beginning, which we lacks in our understanding in our mechanics. So I think to get an opportunity to understand quantum mechanics is a blessing for him or her, because he describes how works, because it describes how the reality works on the best and fundamental level, on the root level, in the tiniest of scales. It describes very beautifully, and because of quantum mechanics, all the technologies, satellites and telephones, and all the smartphones you used is developed due to this our understanding of quantum mechanics. Quantum mechanics works so that we can use those beautiful technologies to shape our era and going to evolve us as a human creatures, and it is very important so that it's very important for us, and we are very grateful for that matter, and this quantum mechanics works so that the universe exists and works beautifully, because if quantum mechanics don't work, then atoms would be unstable and would not be formed. Stars don't form, we don't form, galaxies and all the beautiful creatures in galaxies and universe, it would not occur without this beautiful root level mechanics. We all describe as quantum mechanics. So thank you for joining me today. Hoping to see you again in the next episodes. So thank you.